right, good evening, everybody, and welcome back to another live stream. So apologies again that I was not able to make it last Friday. I think I had mentioned before that I was going to be at my sister-in-law had a baby shower down by St. Louis, so that's why I was not able to make it. It's just been a crazy busy summer, so that's why I've not been able to get to do many of these live streams, but I had some free time this evening, and I thought I'd go ahead and do a little bit of a baby live stream, if you will, in the sense of, like, this is not going to be an overly complicated one. It's right there in the title. It says 101, so we are going to be covering a relatively simple topic. So just a quick note. So if you're wondering, are we going to get back to the movie ratings model with deploying our inference API to Heroku? Yes, definitely we will. And so I still need to do a little bit of cleaning up on that. So unfortunately, I'm not going to be able to do a live stream again this Friday because unfortunately I do have another thing going on. We'll see. We'll see when we get to that. But so tonight we're going to cover what Docker is. Just covering what we're gonna do is we're gonna cover what Docker is, why Docker is important, and how I specifically use Docker for my day-to-day work, and then I'm gonna show you a little bit about like how to actually use Docker, and hopefully we'll culminate with actually creating our own Docker image and running it, specifically running a little fast API kind of thing. Now, the one stupid thing I did right before the stream started is I saw a button in here that said to update my Docker, and I accidentally clicked it, so I think it's trying to update right now. So hopefully we'll be able to demonstrate what is Docker. So let's talk about what is Docker. So Docker. Actually, let's take a step back even. So you all know what this is. This is my an iPhone, and I don't know if you could see this real closely here. So if you notice, the 2 is kind of hidden behind there. What that means is I am actually running the newest beta version of iOS 16. Ooh, the camera got really blurry there. Sorry about that. I'm running the newest beta version of iOS 16, and which added several new features. So one of the new features is oh my gosh, why can't all right, camera refocus. Sorry. All right. So one of the new features of iOS 16 is if you are iMessaging with a friend, and let's say you make a typo, which I make typos all the time. That camera just does not want to refocus. This is bugging the heck out of me. Okay. Bring it back. All right, what if I stick my head out of frame? Okay, note to self, do not stick my iPhone in front of the camera again because then it doesn't want to refocus. All right, what if I come back here? All right. Sorry, this is really bugging me that the camera doesn't want to refocus. All right, I'm just gonna cover it for a second. Okay, how about now? All right, well, I don't know what happened there, but my camera doesn't want to refocus. Anyway, as I was saying is, with this iOS new update, if you are iMessaging with somebody and you make a minor typo or something, you have 5 minutes to go back and you can highlight that text and you can make the change to it appropriately. So that's kind of nice. But there's a caveat to that. And the caveat being is your friend also has to be on iOS 16. So, even though I am on this new public beta version that just came out yesterday, most people out there probably don't have that. And so this feature is kind of worthless for me. And so my point is when it comes to software, with iPhones, computers, with anything that we come with coding development is with new versions come new features, and also features get deprecated. And so that is a big concern if you want to if you are deploying out something to production and you want to ensure it runs the same today, tomorrow, and in perpetuity. Because, for example, let's say you have a production application that is running, I don't know, the latest version of Python. And let's say it goes down, and then when it comes back up, you have it rebuild the latest version. Well, what if the newest version of Python didn't have what was compatible with your old stuff? And so we are really, in the software development community, we are really concerned about ensuring that we are hardening our dependencies. So whenever we are using a Python version, we want to make sure we're constantly using the same Python version unless we specifically make a concerted effort to do an upgrade. So historically, the way we have managed that in the software engineering community is with the assistance of virtual machines, or VMs for short. And so virtual machines are still largely used today in many different capacities. However, there are some downsides to using virtual machines. And namely, the biggest downside for using virtual machines is, when you create a virtual machine, you have like this server or a computer somewhere that you're basically partitioning part of your computer to do separate things. And so let's say you have two applications, one of them that's running Python 3.9 with a couple little other dependencies. That camera is never going to refocus, is it? That's going to drive me nuts. So anyway, so Python 3.9, and then you have another deployment that's also using Python 3.9, but a couple other different dependencies. So maybe the first one's using Fast API as their API source, and then the second one's using Flask. So you don't want those two to commingle. So that's why we use the virtual machines. But then you have basically two versions of Python 3.9. So let me go ahead and share my screen here to kind of illustrate what the point I'm trying to get at here. So, okay, so this is just a basic diagram I found on the web here. So off on the left here is a representation of a virtual machine. So most people, just for context, by the way, most people I don't think really understand what's going on with Docker under the hood. And when we get to the point when we actually build our own Docker container, this stuff kind of doesn't really matter to us. We don't really understand what's going on here, but it's kind of, I hope this is helpful for you to conceptually understand where we're going with this. So you can see here on the left, as I was saying, if you have application A, and then it looks like we have application A prime here, we have these orange binaries and libraries, they're the same, but notice that they are duplicate copies. So we're basically eating up a bunch of space that unnecessarily for the exact same thing. And we want to be able to share these things across these different applications if possible. And again, with the segmentation between the applications, because we do not want application A or an application A prime to necessarily commingle with one another. Okay, so you can see here that this is very weighty. So this is not really an ideal setup. So when we come along to Docker here, what it does is it recognizes, hey, application A and A prime, it's using the same binaries and libraries. Application B prime, it looks like it's just B prime and copied a couple different times. But basically what I'm saying is they're able to share these resources. So it's a much better efficient use of your resources. And so that's the big reason that we use Docker. And so it's basically cut, and you'll notice here what the graphic is trying to represent here is, with the bars being so much larger on this side, is that this is a very weighty setup. And notice there's only 3 applications on here, whereas this one is a lot more condensed, and you have Docker that's kind of managing all this behind the scenes. Hold on, I want to check. Is my audio working just fine? Yeah, application A. Okay, my audio is working just fine. Okay, so, by the way, I am monitoring chats both across LinkedIn and YouTube, so if you have any questions, feel free to drop a question in the chat. I'd be glad to answer them. So that is Docker at a very high level. Now, why do we use Docker, or what is the context in which I use Docker? So like I said, what my specific job at State Farm is packaging and deploying machine learning models into a production environment, which is very much a software engineering activity. And so because modern technology like Amazon Web Services or even Google Cloud Platform, or even like a Kubernetes cluster, and maybe we'll do another session on Kubernetes in the future. So if you don't know what any of those are, that's okay. But what I'm trying to illustrate here is a lot of modern technology is founding its basis on of software segmentation and not using virtual machines, but using Docker containers. So if any of you have watched any of my previous live streams before, you've probably seen me build a Docker container. I know that whenever I did my SageMaker one, whenever we deployed our SageMaker API, our inference API for Titanic that we did a couple months back, I uploaded the Docker image up to AWS and made use of that behind the SageMaker endpoint. And so, you don't just have to use Docker, of course, for just machine learning purposes. Docker is used basically across the board for whatever you can think of. Anything that you would have used a virtual machine for, you could use a Docker container for. So that is the very, very high level of what Docker is. Okay, so if you want to make use of Docker on your own machine, I'm going to go to just Google Docker. You will download something called Docker Desktop. I'm not really going to walk you through here how this works. Just the one thing I do want to note, so Docker is, or what was open source. I guess I really don't understand what their their model is, because just a couple months ago they recently started charging for enterprise customers. So no worries if you, like you or me right now, we're just doing stuff on our personal machine, so it's all free for us. So if you want to play around with Docker, you will have to come out here and then download it appropriately. I don't see where you download it on here, but basically, like, you download it just like you would any other application on your Windows or Mac machine. So I already have Docker installed on here. And then, so like I was saying, coming back to here, the way that both virtual machines and containers work is that we create these things called images. And so what an image is basically a grouping of binaries and libraries that we need to support anything for whatever application whatever application. And so what many people have done is they create these base level Docker images that you can basically download, and then you build on top of those images. So for example, let's say I wanted to build a machine learning fast API inference thing. And this is actually what we're going to cover as part of our demo here in a little bit. What I would do is I would go out to a Docker Hub, and I would look for maybe a Python image. And then after I download or set the Python image of whatever that may be, Python 3.9, and I'll show that here in a second. Then I would install what I would need on top of that. So that's when I would do my pip installs. And so then I'd install Fast API, and then I'd copy over my source code from my GitHub repo. I use GitLab at work. That's why I had a little bit of flub there. A GitHub repo, or even just a standard Git repo, into the Docker container, so then I can make use of it from the Docker container. And then we'll cover all this, of course. But I do want to show what Docker Hub looks like real quick. So let me go ahead and just show you here. Google up some Docker Hub. So Docker Hub, this is the primary place where you can look at pretty much any image. So like, let's say I want to load Docker Hub Python. So there are lots of different images, and they have lots of different purposes. And if this is kind of scary to you, just note that most people, whenever they land on a Docker image that works well for them, they generally don't change it. So for example, if you've seen me do my work in the live streams, you'll notice that I use primarily one of these Python images, specifically Python 3.9 Slimbuster. And if you're curious what Slimbuster is, beats me. So I know slim means like it's it tries to strip away like some of the extravagancies to like get down to like a more basic and slim version. I don't know what Buster necessarily means. I don't know what Slim Bullseye means, but like you can see there's a lot of different variants. So we got Python 3.9, Python 3.10. Oh, I didn't even know we were at Python 3.11 yet. Okay. Well, anyway, I think in our live streams recently we have been using Python 3.9, and I think I am going to stick with that for now. But I just for fun, I did want to show that if you are testing things out, we can use what is called a hello world image. So that when we actually run this, we can do a hello world. So let's go ahead and show that real quick. So I already do have Docker installed on my machine. So if you want the Docker command line interface, CLI installed on your machine, that comes along with the Docker desktop to download here. So if I open up my terminal here, ooh, golly, didn't mean to do that. All right, so if I just do a Docker help, then you can see that I got my Docker CLI installed here, and then it shows all the different things that you can do. So we're just going to do a couple of these. So you could see over here that Docker Hub provides this thing that says you could do a Docker pull. So this is how you actually download an image. So actually the interesting thing is so if you want to run a Docker image, naturally the command is Docker run and then whatever the Docker name is. So if you did not already have the image already installed to your laptop, it would go ahead and pull the image first and then run it. So let me go ahead and show you that in one fell swoop here. So if I do, let me clear that out, Docker run, what was it called? Hello world. Okay. So it's unable to find the image locally, so it's doing a pull. And there we go. It's a very small image, so it went very fast. So it just downloaded this. And the only purpose of this Docker image is just to show hello from Docker. And so you could see it's just showing a basic message, and then it exited out. So that is a very, very basic Docker image. So, we've already pulled our first image, and yeah. And that's the end of the live stream. Good night, everybody. Just kidding. All right, so that is our basic Docker how to pull an existing Docker image. Now, of course, you are going to want to create your own Docker image. So I am going to create a very simple fast API application, just one that just does a health endpoint, and yeah, then we'll go ahead and then we'll Dockerize it. So let me go over to my terminal here. So this is a fresh little repository. This is actually this Docker 101 that I just created on my desktop here, because I'm just going to delete it when I'm done here. Nothing in it at all. Well, actually, I think if I did a yeah, so there's just like the IntelliJ files in here. So I got IntelliJ open over here. So let's go ahead and do a new file, api.py. So let's create a basic Docker file. So, or I'm sorry, a basic Python script that's going to do the fast API. So from fast API, import fast API, and then I'm also going to import some responses. From fast API dot responses, import JSON response. Okay, so just importing those. Then let's go ahead and instantiate our API object as so. And then let's go ahead and just add one get endpoint. So api.get, and then we're going to call this our health endpoint. We're just keeping it super simple for tonight, because this is not the purpose of this this live stream. So health, and then we are going to did I do that syntax right? Why didn't I? Okay, we're just going to return JSON response status healthy. Okay, so another thing I want to do here really quick is I'm going to add a new little shell script that will be initiated by our Docker container. So I'm just going to call this run.sh, and then we're going to use Uvicorn to start this up. So we're going to do Uvicorn. Here, let me make that a little bit bigger. Uvicorn, we're going to host it out on host 0.0.0.0, port 8080. And then the syntax here, so remember, this is I think we covered this in the last live stream. So this is the api.py file, and then within this is the actual API object. So that is what we're going to run. And so I can't see my screen. Okay, so if I open up a basic terminal down here, so I should just be able to run this really quick. So bash run dot bash run dot sh. Okay, so api.py is running down here. So if I open up another tab, so curl localhost 8080 health status healthy. So if I come back to here, you can see that this API, this fast API is working just fine. So we are ready. So now this is basically that's basically the syntax of a very simple Python file there, or a fast API file there. So now let's go ahead and Dockerize this thing. So the way we do that is we use something called a Docker file. So there is no extension on here. It's a little bit odd. It's just called Docker file. And so the first thing that we need to do at the top is we need to instantiate whatever base image that we want to use. And just for reference, in case you're curious, you can create a Docker file totally from scratch. I personally have never done that, and I have never seen anybody do that. So just for your awareness. So we, like I said, we are going to use a base image of the Python 3.9 Slimbuster. So the way that we do that is we use this keyword from. So actually, you can use commenting just like you would any other Python file. So I'm going to do instantiating our base image. Okay, so from Python, all right, 3.9. All right, so Python, this is the official, like if we come back to here when we were looking at all these, so these are actually all different tags. So we have our collective Python image here, and then we set the tag. And so the way we set the tag here, so we do Python and then colon, and then we put the tag name there. So it's Python 3.9 Slimbuster. Okay, now we can do a number of different commands here. So in terms of the number of different commands that we can do here, we can run different little shell scripts or run different little commands to actually install things, which is one of the things we're going to do, because we are going to do a pip install. Oh, that is one thing I forgot to do here. So I'm going to use a requirements.txt file to actually keep track of my dependencies. or my Python dependencies, that is. So requirements.txt, and inside of here, I am going to stick in the Fast API and Unicorn Python dependencies here. So in case you're curious what this means, this is saying, okay, I want Fast API and I want it to be this very specific version. Now, keep in mind, this is where it's really important to actually version pin your things, because if I were to just say I want Fast API, period, it's just going to grab the latest. And sometimes it's fine, but again, as software changes over time, things get changed and it may not work with your code. So that is why it's always super important to version pin your things like so. So we have this requirements.txt file, our API.py file, and then the run.sh file. Okay, so if we come back into the Docker file, we can do a lot of different commands. So let's go. So there's the run command. So, and by the way, the syntax for a Docker file, all the commands that a Docker would run are initiated or start with like a capital letters like this. So from FRM is all capitalized there. Now, another thing to note is as you build a Docker container, well, I'm getting ahead of myself a little bit. All right. So I am on, as a reminder for you folks, I am on a Mac M1 chip, Mac Mini. So in order for me to get Docker working, I had to do some special things. So I actually had to install some apt packages or like Linux packages. So in order to get this thing working, so I'm going to install installing Linux packages. And so like what I need to do here is I need to do a run command. And so I'm going to initiate this command apt get, and then I'm going to do this flag yes. So let's not worry about what this is doing necessarily too much. But the one thing I just want to note here is we are running this command apt get from this base Docker image here. So if this base Docker image did not have this apt get in here, we'd be up a creek. So that's why we select very specific Docker images that will serve our purpose in a different capacity. And again, if you wanted to create a Docker image purely from scratch, it's possible. I've never done it. I don't even know how to do it. I'm sure I could Google how to do it, but I would not recommend it. So I need to run this apt-get update, and then I need to actually install some other things here. So apt-get install. I need to do this gcc lib XML2. So again, don't necessarily worry about what this is doing. This is just because I'm going to call this dependencies. This is because for some reason, if I don't put these things in my M1 Mac, it just doesn't want to work. Okay, so does that make sense? I hope that all makes sense to y'all. All right, any questions? I'm checking for questions. Okay, no questions. All right, now what we need to do next is we need to install our Python dependencies. And so the way we install our Python dependencies is first, just be aware that whenever we install, like whenever your Docker image is starting to do its build here, it is not contextually aware of whatever is inside of your overall Git directory or Git repository in general. So we actually have to copy that file first from your directory into the Docker container, and then we can make use of it. So for the requirements.txt file, I'm going to call this installing Python dependencies. So we're going to introduce another keyword here, the copy command. So copy. So what we're going to do is copy the requirements.txt, and then I'm just going to put slash so this is going to look very familiar to you. So if y'all are Linux folks, so it's more or less the equivalent of the cp command. So copy requirements.txt. It's just that it's all this capital letters copy. So it should not be very. You'll find this is actually pretty simple. And again, if you're like me or any of my coworkers that I work with, once you figure out like a base image, you're not really going to go fiddling around with it unless you like something like drastically changes. And so like in all of my live streams, you'll see me basically just copy this whole syntax here from another Docker file. And the only thing that we change is the actual source code that gets copied into the repository. So now that we've copied our requirements.txt file here, let us, we need to actually do the pip install. So run pip install r / requirements.txt. Okay, so this is actually running our command. Okay, so one other thing that you noticed here is that we served our our fast API instance out on port 8080. So this is natively. I actually some of these commands can honestly be a little bit ambiguous if you need them or not. So we're going to put this one in here, but I'm not entirely sure if we need it. But basically, we need to expose port 8080 out of the Docker container for usage. And the way we do that is we're going to introduce another keyword here. So we exposing port 8080. And can you all guess what the keyword is? Anybody? Expose. Expose 8080. Okay, so now that we have exposed port 8080, now I want to do we are actually going to copy our copying our API Python file into the container. All right, so there we go. Now I'm going to, again, this is going to be very familiar to you. So I'm going to do copy api.py. And, this part doesn't necessarily matter, but this is the only reason I'm so used to doing it where I'm going to put this is just because when so actually if you do work with Amazon SageMaker, they do require you to have a very specific sort of syntax for your Docker container. It's nothing overly complicated, but because I'm so used to it, I'm going to put my files into opt/program. So this is actually where AWS SageMaker recommends that you put their stuff. So when we actually initiate our Docker container, I guess we need to also copy over. So here's something interesting. Copy run.sh, also an opt.program. So something to note here. You might be wondering, well, does it matter if I put run.sh before or after the API.py file here? And the answer is yes. And the reason this matters, and this is what I wanted to get to, is the build. When we actually go to build this Docker image here for usage, it will work from top to bottom. And so it will start by pulling our base Docker image, and then installing these Linux dependencies, and then doing this other stuff, blah, blah, blah. And the reason this is important is because if you actually went and built the image again, it will try to, what the Docker is smart enough to cache what you did before. So let's say I make an update to api.py here, then all this stuff, if we already did the Docker image before, it's just going to say, all right, already done, let's not do that again. So it saves a lot of time if you actually set these things up in such a way that you don't run these things multiple times out of order. So basically, because this file here is probably the one that's most inclined to change, this would be pretty stupid to put toward the top, just because then you'd have to do this full Linux dependency business again. So again, that is why we do this. So I'm copying these things over now. By default, I don't know what by default the directory is of the Python 3.9 Slimbuster, but if you want to set a working directory, you can do that with a new keyword. So let's introduce another new keyword, setting the working directory. So the keyword here is workdir, and then we're going to call this opt/program. And then I think that is it. Okay, let me review here real quick. Yeah, I mean that's more or less it. So I guess just there, because we don't need to do anything else, but just to make you aware, if you want to set an environment variable for whatever reason, the keyword is just env. I'm sure you could just Google out there any sort of syntax for a Docker file, or just searching GitHub for lots of different Docker files will give you ideas for different things you can do. But the ones that I've showed here today are the big ones. These are the ones that I personally use the most often. Okay, so so this Docker file should be good to go. And the way we actually build the Docker file is, let's go over here, clear this up. All right, so cd, where am I at right now? Okay, cd desktop, cd docker 101. All right, clear this out. All right, so we are going to do a Docker, here, let me make this bigger for y'all. All right, so Docker build. All right, so if you see this .t flag, so what this .t flag is basically saying, okay, I want to name my image this. So I'm going to call this image Docker 101, just because that's what we're doing. And you can set a tag here if you want. So I'm just going to call this Docker 101 latest. And now here's the weird thing is you have to put a period at the end here. And what the period at the end here represents your build context. So it's saying, okay, I want to build my Docker file from this directory, because here, this is where my Docker file is. You can actually set a flag that specifically notes where your Docker file is if it's not in the same directory where you're running your Docker build command. But if your Docker build command, if your Docker file is in the same directory of your Docker build command, then all you need to do is this period here. So let's go ahead and run this command and let's see what it does. So what it's doing right now, it is downloading Python 3.9 Slimbuster from Docker Hub. So that takes a little bit. And now, so you can see we're on step 2 out of 8. Now we are doing our Linux dependency run. So you can see this isn't taking too terribly long. If you have a really robust Docker image, this can take a while, which is again why we really like to make use of caching, because if for whatever reason we needed to change out something from the some other thing, workdir. Okay, what happened there? Something happened. Error workdir. mkdir merged not a directory. Huh, what did I do wrong here? Oh, well, okay, I think I know what I did there. So, because I'm not used to actually copying things over like this, I actually just copy over a full. So let me go ahead and stick these in a source directory. All right, so I'm going to call this src. I'm going to put these couple things here, the api.py and this into the source directory. And so then I come back to the Docker file here, and instead of, because I don't normally copy over single files like this, I usually copy over full directories. And so instead of doing that, so I'm going to run this instead. Hopefully this works out instead. So, but I guess this is a nice thing, because now I can demonstrate when I go back and do this Docker build command again, you will see that when it's not going to do the download again, because it already cached it on my local computer. And so it's just going to go really fast through these first couple ones. So watch this. All right. So, boom, it went super fast. Did you see that? It did everything. So it did, so there was only 7 steps this time because I omitted 1 step. So it went and built the whole thing in 1.3 seconds. So, and that, as opposed to the 27 seconds that it took before. So, not bad. And you might be thinking, well, why do I carry 27 seconds? It's not a big deal. When you get some fat images like I do, like especially if I'm working on like a TensorFlow or a PyTorch image, oh my gosh, those things can take upwards of an hour to build. So obviously that's not ideal. Whereas, when these things get cached, then it's not a big deal to change these things out. So one thing I do want to note here, again, so if I come back over here and let's say I wanted to go into my source directory and I want to change this from healthy to hello streamers. Okay, so I changed that. Now let's go do the Docker build again. All right, now it should go boom really fast, 0.8 seconds. So it did. Notice it did change everything. The only it did. Well, you can even see the word cache here. So cache, and you'll notice here the only thing that it did new was it copied the newly updated stuff, because Docker is aware that I made a change to that file and thus needed to run this command once again. Okay, so now we are ready to actually make use of this Docker file. So the way that we do that, we already saw run. So the one thing to be aware of is whenever you want to use ports like this, you do have to manually expose them. So like they are not exposed by default to your computer. And so the way that we do that is we add the P flag port, which represents port. So what we're going to do is we're going to say, okay, inside the container is port 8080, and I wanted to mount it to my local machine, also called 8080. And so then I do a Docker 101. And then this is the name of the image, and then 101 latest. And then I'm going to put the command that I want to initiate into the container. And so that is the one thing I didn't demonstrate here is in the Docker file is if I wanted to, by default, say, okay, anytime you run this Docker container, run a specific command, you can actually set something here called entry point. And then let's just call it like run.sh. I don't think that's the right syntax per se. I actually don't typically set entry points because I like to use Docker containers for multiple purposes. So for machine learning specifically, let's talk about SageMaker really quick again. So SageMaker, if you were to actually, AWS SageMaker, if you were to actually want to, you could use the same Docker container for both model training and model inference. So in order to actually use the same container that way, you actually have to have 2 very specific files in there. So you have to have one called train, you have to have another one called serve, and the one as you can tell, the one called train is for would initiate your training Python script, and the serve one would initiate your inference script for whatever. And you may have seen me do that again in a previous thing. So I actually typically don't set this. So when you actually do a Docker run command, you can actually note that I want to run this run.sh file here. Okay, so when I initiate that, run.executable file not found in the path. That's not good. I wonder if it's because I did not do a chmod. So let me see if this will help out here. Running the turning run.sh into an executable file. I'm hoping this will work. So run chmod plus x run.sh. Okay. All right, now let's do docker build. All right. Run.sh no file. Well, am I not setting? Oh, that's because I'm setting the working directory after the fact. Whoops, that's my bad. All right, so I'm gonna set my working directory, and then let's run this. All right, so let's try this again. All right, now let's try to do this docker run command. Okay, not executable file, not found in path. All right, hold on. I'm gonna add this environment variable here. So in case you all are wondering how I'm doing this so fast, transparently, I got a second monitor down here, and I'm just looking at an old Docker file. Like, I don't have the stuff memorized off the top of my head. And again, it's not, memorization is not important. It's nice, but it's more important to understand the syntax of what you're doing. So actually, I'm going to stick an environment variable up, well, right under here actually. So I think it's because I did not have this environmental variable set. So setting this environment variable appropriately. Or I wonder if it's because I didn't have a bin bash up here. Oh, that's probably why. All right. Hold on here. So shebang. That is the literal term. So that the pound sign followed by the exclamation point is the shebang. So bin bash. I wonder if that's why. All right, so let's try this once again. All right, Docker. Oops. I got to do a Docker build, don't I? Sorry about that. Come on. Docker build. Okay. All right, now let's try this Docker run. Okay, now it is serving out my Docker container. And so let's go ahead and open up a different window here. So, because let's say you want to look at whatever Docker containers are already running. So the way you do that is by running the docker ps command. And so that is basically saying, okay, I have this Docker image out here with this container ID. Let me see if I can make this a little bit bigger. And it is running the Docker image, Docker 101 latest. It was initiated by this command. It was created 13 seconds ago. It has been alive for 13 seconds. It is hosted out on port 8080, and then it gives you a random name as like to reference it by. I've never used this random name for anything, but it's nice to know. So if I run this docker ps command, you can see that it was up. It's been up for 43 seconds now. So if I were to do a curl command now, so a docker localhost 8080 health, you can see that I just got my status of hello streamers. And if I come into my command over here, or I'm sorry, my Docker container, running Docker container over here, you can see that we did get a 200 status, basically saying, okay, great, we got the curl command, and we returned the thing back, and it was all good to go. And friends, that's it. That is Docker 101 for you. So that's how you build your own Docker container. And so I hope this gives you an idea of a flavor of like all the different things that you can do with Docker containers. And again, so most of this stuff here, well, actually, so let me go ahead and shut down my Docker container. And oh, I forgot that it's kind of weird to do this. All right, so the way that we actually do this is, so you grab the container ID, and you could do one of two commands. You could do, a Docker stop or a Docker kill. So Docker stop will try to shut the Docker container down gracefully, whereas a Docker kill just says cut it immediately. Honestly, for this one, it doesn't really matter if we do either. So I usually just do a Docker kill because it's faster. So that is killed. So let's do a Docker ps now, and it is gone. And I can't believe I just got away from that directory. Dang it. All right, so desktop All right, cd docker 101. All right, ls. And again, let's just demonstrate one more time. So like if I wanted to come back in here and say, hello, my fellow humans. Hello, my fellow humans. All right, so let's again run this again. So docker build. So we're running the latest build command. All right, boom. So all right, now let's do a docker run. And because I have caching on my computer, I can just run this command once again. All right, so we have started this up once again. All right, now let's do a curl over here once more. Hello, my fellow humans. All right, there we go. And so let us go ahead and docker ps, and let's go ahead and kill this thing, because before I forget, docker kill, and then command, boom, and that should have killed this over here, which it did. Clear, and then is that it? Oops, sorry. Docker ps, so we should not have any Docker containers running anymore. Yep, all gone. All right, and anything else I need to cover really quick? Any questions? Nope, no questions tonight. That's okay. Yeah, so that was a nice little concise little live stream. How about that? 45 minutes. So yeah, that's all I wanted to cover tonight. Just a very basic introduction. Oh my gosh, my camera is still blurry. Ugh, why? Okay, note to self: don't shove iPhone in front of camera again. So that's all I wanted to cover for today. Again, we will be back with something more machine learning related in a future live stream. Golly, why is it down? Yeah, I'm gonna go read or something and go to bed, I guess. So thank you all again for watching. Hope you all enjoyed this, and we'll see you in the next stream. Good night, all.